Hi, welcome to this course. Myself Muhammad Yaqub, I am the founder of ScratchLearn. In this project, we are going to learn about AI-based age and gender detection. For example, customer demographics. For example, if you take any kind of industry from retail to airport, public spaces, healthcare, if we take any industry, customer profiling is the very important scenario. For example, we can take any mall. Okay, so based on the number of customers or the different age category, based on that only all the shops inside, they will be planning all their inventory and everything. If the specific age group, for example 30 to 40 and 40 to 50 is the major entry in the store, then all the inventory will be planned based on the customer profiling. So like in healthcare, in retail, in all the place, customer demographics and profiling plays the major role. So in this project, we are going to develop AI-based age and gender detection system. We are going to use ResNet 50 model, pre-trained model for detecting the age and gender, and also we are going to integrate multiple computer vision concepts like OpenCV, different kind of library we are going to use in it, and also we are going to use Tkinter graphical user interface for the front end. So all integrated, we will be presenting you and you will be learning how we can develop AI-based age and gender detection system.
Programming language to implement our entire project. For that, we need to install a Python IDE. We are going to use only a specific version of Python for implementing our entire project. For that, we need to install Python 3.12. And if you have already installed any other version of Python on your machine, then it must be uninstalled from your machine. So let's see how to install Python on your machine. First, you need to go to Google and type in Python 3.12 py release. Then scroll down. Select the Windows installer 64-bit. Then simply click to run it. Then select Add Python to Path. Then click Install. Now Python is successfully set up on my machine. Then close it. Now we can go and check the Python version using CMD. py-hyphen version. On my system, the Python version is 3.120. Now we can go ahead and implement our project. Before implementing and executing any part of our project, first we need to install VS Code on your machine. And if you already installed VS Code on your machine, then that's perfectly fine. This guide is for those who have not yet installed VS Code on their machine. Let's go through it step by step. VS Code is a platform that makes it easy to build applications. To install VS Code on your machine, first you need to go to Google and type VS Code. Then press enter. Select Visual Studio Code from the results. Then click on download for Windows 10 and 11. Now the download has started. We need to wait a few seconds for the download to complete. Now VS Code has been successfully installed on my machine. Then I go to the folder. Then right click on the file to install. Next, accept the agreement and click next. Next. Yes. Next. Next one. Install. We need to wait a few seconds for the installer. Now VS Code has been successfully installed on my machine. Then click finish. Now we can go and check the version of VS Code using CMD. Then type CMD here. Type code version. The VS Code version is 1.953. And now we can implement the project step by step. I'm going to give a brief overview of the project. The project is called Age and Gender Detection. With this project, we will explore age and gender detection using a pre-trained age and gender detection model. First, we capture frames using the integrated camera. Then the captured frames are fed into an ultralight face detection model. Next, the detected face is passed into the age and gender detection model. And finally, we obtain the output for age, gender, and the gender score. Finally, we will display the output frame in a Tkinter window. This is the pre-trained age and gender model weights, and this is the creative model used to set the pre-trained model weights. Cross bottleneck attention. This is the pre-trained model. This is the age and gender detection estimator, PY file. This is the model inference code. Model inference is under requirements, txt, which is used to install the libraries needed for inference. Then sort is here. I use this technique to assign a unique ID to each detected face. Let's dive into the project code explanation as well as how to run the code. First, you need to open VS Code using, so you need to replace it here with CMD, then type code space dot here. Then it will redirect you to VS Code. Now VS Code has opened successfully and the project folder is named Age and Gender Detection. First, we need to import the necessary library for implementing the project. The libraries are CV2. CV2 is an OpenCV library that is used for image processing and image handling. And NumPy, which is used to handle arrays of data, which is faster than using lists. This is the main reason for using NumPy arrays. And then import message box from Tkinter. Then sys, which is a basic Python library used to handle some basic Python operations such as exiting from the terminal. CVZone is a function that is used to display text in an OpenCV window. Then regular expressions are used to remove unwanted text from a sentence. Then OS is a basic Python library that is used to handle some basic Python operations. Then import all Tkinter modules from Tkinter, which are used to build graphical user interface implementations. Then import field dialog from Tkinter. Then Pillow, which is an image processing library. Threading is a Python function used for multiprocessing tasks. Then date and time are used to get the current date and time with this function. Then import Tkinter as TK. CSV is used to download logs in CSV file format. Shuttle is used to copy a file. Then import the age and gender models from model inference. Then transforms is a function used for torch preprocessing format. Then ultralight det. It is ultralight detector, which is used to load and detect faces using the pre-trained model. Then sort is used to assign a unique object ID to each detected face. Then define an ultralight detector, which is used for face detection. And the model input size is 640 and 480. 640 denotes the width of the model and 480 denotes the height of the model. And the TensorRT execution provider is not available because there is no GPU in the system. So TensorRT execution providers are not supported. Only CPU is supported for this model. Then define an age and gender model. So you need to provide the model file path here. Then the device is set to CPU since GPU is not available. So set it to CPU even though during model inference it does not detect a GPU. This is the main reason for using CPU here. Precision is set to half, FP16. Use person is set to false. Disable faces is set to false. Verbose is set to true. Then initialize the three important variables. The variables are running, video capture, age, gender, and rows. Initially, the program execution has not started. So set it to false at first. Then once the program execution starts, set it to true. Video capture is initially set to none. Once the program execution has started, assign 0 to this video capture, which is used to capture faces from the integrated camera. This is used to store age, gender, face ID, date and time, and image path in this list data type. Then create a new folder to store the captured faces in this directory. The folder should be named face image. If this folder does not exist in the directory, then create a new folder called face image. Save as CSV is a function used to store logs in CSV file format. The field dialog is used to enter your file name along with the .csv file extension. Once the file is created, check whether this file exists or not. If the file does not exist, then return an empty result. If the file is available, then write the age and gender information data to this CSV file. Next, this specifies the file path. The mode is write and the new line and encoding are set to UTF-8. Then, as the file is open, write the information to the CSV file using CSV writer. Use writer, writer-o, then iterate through the data with the for loop and use writer, writer-o. Once the for loop has executed successfully, a message box will be displayed here saying success, data saved successfully along with the file name. If any error occurs in this try block, the except clause will throw an error message, failed to save CSV file. This is a set data type used to store face IDs. It does not allow any duplicate face IDs and only stores unique face IDs. Next, define the transforms. This is a function used to pre-process an input image into the correct model format, converting it into pillow 5 format. Then this is set to the model trainer size. The model trainer size is 224 by 224. Next, convert it into PyTorch tensor format and then apply normalization. Once this normalization is applied, all the pixel values fall between 0 and 1 and the mean is 0.485, 0.45, 0.4. The standard deviation is 0.22, 0.22, 0.225. Video stream is a function. All the model inference takes place within this function. Then use some variables as global variables, which allows you to access a variable inside the function using the global keyword. The variables are age, gender, rows, age, gender, data, and video capture. Next, initialize the tracker with the important parameters. The parameters are max age, min age, and the IOU threshold, which ranges from 0 to 1. The maximum threshold is 0.6 and the minimum is 5. Then the max age is set to 100, which is used to allocate a unique object for each detected object. Next, get the original frame with the date, then initialize the count values to 0. When the model inference starts, the count will be increased. Then padding of 20 is applied here, which is used to extend the face region. After applying this padding value to the detected faces, the image height will be increased based on the padding value. While running, the process continues until we stop the execution. Then video capture is used to read from the integrated camera. The output frame will be stored in the frame variable. The return value is either true or false. If it is false, then execution stops, and if it is true, execution continues. Then a display window is defined with dimensions 800 by 450, which is used to display the output frame in a ticker window. Then CV2 IMShow is used to display your frame in the window with the specified size. Next, a detect function is defined, which is used to detect a face. Then the output of the bounding box coordinates and the scores, which are the confidence scores from the face detector, are obtained. The face boxes variable is used to store the bounding box coordinates such as xzone, yone, x2, y2 along with the confidence score. Then iterate through the results using enumerate in a for loop and convert the zone, yone, x2, y2 coordinates into integer format. Then apply padding. This is the starting point of the value on the x-axis. This is the starting point on the y-axis. This is the image width and this is the image height. Then crop the face using yone to y2 and xzone to x2. And the face region will be saved to the variable cropped face. Actually, the confidence score range is from 0 to 1, but here we are going to convert it into a percentage by multiplying by 100. So the confidence score becomes a percentage. Then convert the crop phase from BGR to RGB format, which is used as input for the age and gender prediction model. Then a transform is applied to add a dimension, making it 1. Actually, the model can handle a lot of batches like 16 or 64, but when we give one input to the model, the batch size is 1. This is the channel, this is the height, and this is the width. This is the object we created for the age and gender model. Then call the predict function using the created object. So we need to give the cropped image to this function. Then get the output of the age and gender score. Once this function is called, it will go into the model inference file, access the input image, and then feed it into the inference function. Then get the input image and make inference using this trained model, and do not apply gradient descent or compute gradients during inference time. Then self FPS 16 means the model input is in floating point 16. Then get the output of the age and gender score from this model. First, we need to import the necessary libraries to make inference. Optionally, CV2 NumPy Torch is a deep learning framework used to train deep learning models. Then make inference using the trained model. Then create model is a function used to make inference. Then resolve data configuration. Then transforms. Then check if CUDA is available in the system. If there is no CUDA available, then it will not allocate floating point 32 and also will not apply backends like QDNN. This is a Python class. The class name is meta, which contains a lot of functions. This is a constructor which is used to define variables in this constructor and then access them inside the function using the self keyword. Initially, these are some important variables: min age, max age, average age, number of classes, and the input channel is 3. The model we are training uses people with faces. So we set this as false. Use persons set to true. Only age set to false. Number of classes for gender is 2, male and female. And then the model input size is 224. Load. From CPT is a function used to load a pre-trained gender and age detection model using torch. Load. This is the torch load function which loads the model using the CPU and then retrieves min age, max age, average age, only age, only age. We're trying different combinations with the model. And then self, disable faces, disables faces in the person model. The model we're training uses the person model. This is used to load access to the pre-trained model. The number of classes is 1. If only age, otherwise 3. Self input channel is 3. If not, self with person, otherwise 6. Use persons with self, with person, model, and then self. Persons, model disables itself. You cannot use disable faces for a faces only model. Then this condition will not be met. Then update the variable, and this is a special kind of method called a property. Use persons crops, which simply crops your faces and persons, and this is the age gender model. So CPT checkpoint file path, which uses string format with 5 placeholders. Then if CUDA is not available, as we've already specified, CUDA is set to CPU and then off is true. Then disable faces, use persons, verbose, torch, compile, then devices is set to CPU and then load the model from CPT. So self model will be created here. Then perform inference using this model, which is also used to count the number of parameters available in this model. Then resolve the data config, self model, set verbose to true, and then set self data config crop PCT value to 1. Next, the input size. If the input size does not match the width, then the config is incorrect. The model trainer input size should be 224 by 224. Then run it on the CPU and compile the model if this is set to true. Otherwise, it will not compile. Then the model runs with FPS 16, that is floating point 16. This is the inference. Then if self meta only has age available, only the age will be written and nothing will be returned. Gender probabilities and gender index. For the age output, assuming this is the third column, the age output and the gender output are probability values. Based on that, we can take it, and then for gender probabilities, okay, 1, then multiply by width, then access the age output, then multiply by width, and meta max age and meta min age and self meta average age. Then get the rounded value which only removes the decimal points, and then if gender probabilities are not none, then get the gender as male, and then the gender score. Then finally return age, gender and gender score. Then finally take the output of age, gender and gender score from the return of this function, and then print your age, gender and gender score. Here we are going to select faces only if the confidence score is more than 70%. If it is below that, we are not going to use it for further processing. Then it will be fed into the face boxes tracker, which is used to assign a unique ID to each face. Then iterate through the faces using a for loop, convert them to integers, and then get the output values of zone, yone, x2, y2 and the face ID. Then CV2 rectangle is a function used to draw a rectangle around the detected face. Then CV2 put text is a function used to display text in the OpenCV window such as age, gender and face ID. And these are the x and y coordinates where the text will appear in the OpenCV window. This specifies the font name, font size, thickness, and this part is for the color. This is the if condition used to check if the face ID is not already in the age gender data. If not, it adds the new face ID to the age gender data. If the face ID already exists, then it is not allowed. Next, apply BGT work B to the cropped faces. Then adjust the brightness here for the cropped face. The brightness will be increased by up to 20%. Then apply contrast and sharpness adjustment zone, 0.4 for contrast, 2.5 for sharpness end. Then save the image after applying these enhancement techniques. The file format is PNG and the file name is face image followed by the face ID count. This is the face image folder. Next, access the current date and time, then define an image path, and then perform age and gender detection, which is used to display results in the Tkinter log window, such as face ID, current time, age, gender, and the image path. Then append this data to download it in CSV file format, including face ID, current time, age, gender, and image path. Then convert it to BG to RGB, which is used to update your frame in the Tkinter window. Then convert it into a NumPy array format, and then convert it into the image TK photo image format. After that, it will be stored as a video label image TK. Then configure the video label and then update it here with root update, which is used to continuously update your frame if it is available. Finally, release all the processed frames and destroy all CV2 windows. Then start the age and gender detection function, which contains two important variables, running and video capture. These are also accessed inside the function using global variables. Once the program execution starts, running is set to true. Then video capture, which is also set to true, is accessed here, capturing frames from the integrated camera. The 0 indicates the integrated camera. If you have an external webcam, you need to specify it as 1 here. Then a video stream thread is created and the video starts. If you want to stop age and gender detection, you need to issue a stop command. Then running is set to false, video capture is disabled, the resources are released, and finally the window is closed. Load image is a function used to open an image with pillow, then resize it to 50 by 50 pixels in height and width, then convert it to an image TK, photo image, which is the pre-processed image. Then finally it returns. Next is download image, which downloads from within the window. This is the file extension, JPG, PNG, which is used to create a new file, and then it will be stored in the save path variable. Check if save path is available, then copy the file using shuttle. The image will be saved successfully. Display it here using the print function. Then save as a CSV file format. which makes it easy to save your data using the CSV file format. Next is age and gender detection, which is used to display age, gender, face image path, date and type, and the object ID information in another Tkinter log window. Induction list, which is used to insert data into this induction list. Then get the row ID, then load the image. The loaded image will be stored in the image reference dictionary. Then this is the label in column 0 with pad X5 and pad Y5. And then this is the download option, which is simply for downloading the image path, image frame, and then downloading the image based on the path. Next, define a Tkinter instance as root. This is the title. The title is age gender detection system. Then geometry, which specifies the Tkinter window size. The size is 1000 by 600 and the window is resizable. This is a Tkinter style window configuration. Different styles are applied using TTK. Then for T notebook tab, the font name is Arial and the font size is 12. This is for the preview heading under the tree view, and then the tabbed interface uses TTK notebook. The notebook is packed with pack. Next, this is the video frame tab, which is simply for displaying the output frame here in the Tkinter window. And then the background is set to black. Then live video. Then the video will be passed to this video frame function. Age is under log, which is used to create another Tkinter log window display here. Age is under object ID along with date and time information. This is an image under the button frame, then an image reference, which is to display the image. This is for AI powered age and gender detection. Then Arial font with the font size set to bold, background set to black, and foreground set to white. Then define a video label, and the Tkinter log window column names are object ID, date and time, age, gender, and the face image path, which are defined using the TTK preview format. The height is set to 15. Then I use a for loop to set the columns, headings and columns. Then pack the induction list. This is a button to download the age and gender detection log as a CSV file. Log as a CSV file format, then pack it, then create a different button frame with start camera and stop camera buttons, which are used to start and stop the program execution with Arial font and a specified font size. The background is green and the foreground is white, and root.main loop. The Tkinter window will keep running continuously until you stop the execution. Finally, we are going to see how to execute the code, obtain the output for age, gender and face detection, and then display a frame in their window. First, you need to open a terminal, a new terminal, and then you need to install the requirements. TXT file, which includes TIM, Torch, OpenCV, and Python. So I'm going to type here pip install our requirements txt, then press enter. Now at this moment the packages are being installed. Now that the installation process has been completed successfully, the next step is to verify which version of Torch has been installed on your system. To do this in Python, first open your Python environment and import the Torch library by typing import Torch. After that, type Torch version to display the currently installed version of Torch, and then press enter to see the output. The Torch version is 2.5, 1 plus CPU. Then I'm going to exit using Ctrl plus Z. Press Ctrl plus Z here and it exits successfully. Finally, I'm going to execute inference. Pop, get this file, copy the relative path, then type py here and paste it over here, then press enter. Now the program execution has started successfully and the Tkinter window has also opened. Then I'm going to set it to full screen and then I'm going to start the camera. Now the model inference has started and now my age is closer to my actual age, and it's predicting gender with 100% accuracy with the face ID as 1. Now the age is continuously updating, and it's getting closer to my actual age. Next, I'm going to show the age and gender detection log. Then object ID is 1 along with the date and time. Then age, gender as male, and the face image path. And then download the face image in PNG file format. Then save it. Then download the gender and age data as a CSV file. And it has been successfully saved to the local folder. The model inference is still running continuously. So now I'm going to stop the camera. Again, I'm going to run the model inference PO file to provide a different input image from Google, maybe of some famous creator or PY, influencer PY, then press enter. Now the code execution has started successfully and the Tkinter window has opened. Next, I'm going to set it to full screen, then start the camera. Which is predicting the age more closely to the actual age, and the gender is male, face ID is 18, which is closer to the original age, and the age is which is being updated continuously in the Tkinter window, then logs. Next, I'm going to download the image right now, specifically from the website as the next step. Then I'm going to download the age, gender, and reduction log as a CSV file. I hope you were able to understand everything from my explanation of the project and how to run the code. I hope you were able to understand everything from my explanation of the project and how to run the code. If you have any questions about the project explanation or how to execute the code, please share your thoughts in the comment section. I'm ready to help you. Thank you.
Hope you enjoyed the course. Course will surely give you solid foundation in computer vision, and then it will help you on your final year projects also, and then surely it will help on your cracking your job interviews. While implementing this project, if you face any kind of difficulty while implementing the project or while setting up an environment, or if you get any kind of doubt, you can feel free to put in the comment section. We will surely help you in as soon as possible in a better way. Thank you.